This architectural rendering represents the ultimate objective of the data center project. The mandate is the delivery of Phase 1, Day 1, specifically outfitting levels 2 through 5. The target is a facility housing a live 2 megawatt IT load. The baseline program allows exactly 13 months, a 397-day contract duration ending on August 27, 2023, to complete the civil, structural, architectural, and MEP scopes. Compare that polished end state with the physical reality of week 0. We begin with a raw dirt plot and a single piece of heavy machinery. The site is highly vulnerable. Every physical action taken in this mud carries compounding risks for the mechanical and electrical systems that will eventually occupy the space above it. This operational playbook slide establishes our starting position, marked clearly by the warning banner at the bottom: System Initialization Conditional Start. The project is authorized for early works, but it has not reached a fully released production phase. 3 specific constraints enforce this conditional state. First, the issued for construction, or IFC, foundation drawings remain unreleased, freezing the engineering baseline. Second, site mobilization is incomplete, with only 15 of the required 26 core staff members physically on site, leaving supervisory gaps. Third, live municipal and state utility lines intersect the immediate footprint, physically blocking the bore piling zone. Increasing the pace of physical excavation at this stage does not generate project velocity. Deploying piling rigs across unverified ground without finalized structural models or clear utility paths guarantees spatial clashes, severed lines, and systemic schedule collapse. This framework establishes the Nexora integrated control system, built on 3 baseline philosophies. 1 record ensures the kickoff sets the definitive starting scope. 1 truth requires every decision leads to a visible owner and evidence-based follow-up. 1 rhythm dictates a relentless weekly control cycle, turning discussion into traceable action. These pillars operate as the primary defense mechanism for the critical path. By forcing every site activity to trace back to an approved baseline, a designated owner, and a dated piece of physical evidence, the system isolates errors before they manifest in poured concrete or fabricated steel. Executing physical work without administrative clearance introduces unquantifiable liabilities. Project velocity is achieved by neutralizing constraints in the administrative layer, proving that rapid physical construction is a direct byproduct of unyielding document control. This diagram illustrates the integrated control architecture, the project's central nervous system, linking the work breakdown structure, budget, design, and HSE dashboards directly to one source of truth. Notice the bottom pipeline. Raw data must survive rigid filtration from evidence through closure before entering the official record. This governance model forces constraints up a strict hierarchy. Daily coordination handles immediate safety at the base. Unresolved issues escalate through specialist branches into weekly minutes, and finally to the steering committee. The MOM issue rule dictates drafts are issued within 1 day. Silence after 2 days constitutes legal acceptance. Accountability is managed through a strict RACI matrix. Whether the interface is design coordination, external utility permits, or long lead procurement, the matrix permits only 1 accountable owner per activity. That owner is bound to a single required by date, eliminating duplicated ownership entirely. Escalations are classified using a precise red, amber, green logic. A red status identifies an immediate block regarding physical safety or critical path execution, requiring instant steering committee intervention. Amber forecasts an impact within the look-ahead window, demanding a mitigation commitment. Green confirms the response is effective and the residual risk is accepted. The entire architecture hinges on the continuity rule. If a subcontractor reports an activity as complete, but the corresponding physical evidence, such as a signed inspection request, is missing, the value is marked not evidenced. The progress is 0. Forcing data through this unforgiving cycle prevents daily site rumors and unverified assumptions from permanently corrupting the official 13-month baseline schedule. Physical execution on the site is governed by 5 construction readiness gates, acting as sequential blast doors across the project timeline. These are mandatory physical prerequisites required before any workfront advances. Gate 0 controls design release. Until issued for construction drawings are formally approved and released, all related procurement and field execution activities remain locked on hold. During Gate 0, spatial conflicts between structural supports and mechanical ducting are resolved inside the building information model before a fabricator cuts a single piece of steel. Gate 1 verifies method and materials. Field teams must produce approved method statements, inspection and test plans, authorized permits, and verified workforce competency records. Gate 2 confirms workfront readiness. The site must be physically prepared with benchmark surveys and cleared logistics paths. Tower crane mobilization is strictly tethered to utility clearance. Gate 3 governs execution and inspection. Supervisors must rigorously verify and log the calibration of their physical tools, generating work inspection requests before covering up any installation. This ensures torque values and testing voltages are legally defensible. If a defect is found, a non-conformance report acts as a quarantine protocol. Work stops. The error is contained, corrected, and re-inspected, preventing concealed flaws. Gate 4 marks turnover readiness. Teams must clear punch lists and transfer operations data to the commissioning authority. Systems remain strictly de-energized until conditions are satisfied. Treating these administrative gates as unbreakable physical laws protects the final commissioning timeline, neutralizing minor construction defects before they compound into systemic failures. Procuring long lead equipment introduces tension. The project manager drives physical installation velocity, while the independent commissioning authority dictates testing sequences and holds ultimate authority over handover. This tag progression dictates energization status. The hierarchy begins at level 0 for design and level 1 for factory acceptance tests. On site, the upper red tag indicates equipment is installed but unsafe. To earn the yellow tag, the system must pass static testing before safe energization. Successful startup earns a green tag. The system then advances to level 4 functional performance, marked by the blue tag, definitively proving its rated capacity and load handling. Testing peaks at level 5, integrated systems testing. This is the pull-the-plug simulation, proving backup generators and UPS systems bridge the power gap without service interruption. Consider a failure mode. Vendor cooling units arrive without verified factory acceptance test data. The equipment is quarantined with a red tag. The dashboard valuation instantly flashes red, an official request is generated, and the steering committee determines if on-site testing can safely mitigate the missing data. Strictly enforcing these factory tests and early static gates is the singular reason a facility survives the brutal stress of the final integrated failover test. Returning to Week 1, this site facility's layout maps constraints blocking early works. Focus on the red hatched piling zone. 3 live utilities intercept this footprint: the municipal PDAM water pipeline, the state PLN electrical cable, and a gas pipeline. Protecting the municipal water line follows a specific protocol. Crews excavate the soil, apply corrosion coating to the pipe, perform precision wrapping, and complete controlled backfilling. Completion is not an estimate. The evidence requirement dictates that exactly 214.9 meters of treated wrapping must be photographed and logged into the dossier before closure. The critical path dependency is the live PLN electrical line. To safely locate it, technicians deploy ground-penetrating radar to map the conduit's depth. That radar data is cross-referenced through a controlled trial pit. Safe excavation controls expose the cable interface, ensuring the utility permit perfectly matches the physical dirt. The bore piling rigs remain entirely demobilized until this electrical relocation is physically signed off by the responsible authority and recorded in the as-built documentation. The final thread is an unmapped gas pipeline. Because its depth is unverified, it sits as an open red risk, requiring an immediate escalation plan. This dashboard establishes the photographic baseline using 3 standardized camera views: boundary, central workfront, and perimeter logistics. By repeatedly capturing these identical viewpoints, the project locks in objective visual evidence of utility clearances and laydown areas. Releasing a workfront is never achieved by eager scheduling. It relies entirely on the meticulous, documented discovery, protection, and removal of physical constraints. Operating this control framework requires a precise human element. This organization chart maps the 26 core staff members, dividing them across head office support, civil and architectural teams, MEP delivery, and the commissioning branch. Currently, 15 are mobilized to site, with engineering roles forming the critical vanguard. The kickoff meeting translates broad alignment into granular accountability. It generates an action register containing 12 strict deliverables. Establishing the 13-month baseline program, submitting HSE plans, and securing the issued for construction drawings are assigned immediate targets and single points of ownership. With the kickoff concluded, the project posture shifts completely. The phase of alignment and planning ends. The focus now transitions to ruthless execution and proving control during week 1. The daily operational rhythm takes over. Field leads must close utility constraints before they escalate into blockers, update risk registers as site conditions mutate, verify installed quantities against the work breakdown structure, and force design decisions through the governance hierarchy. Phase 1, Day 1, covers the first 4 floors and the initial 2 megawatt IT load, but it establishes the structural and mechanical backbone for the entire facility. Maintaining this exact rhythm is mandatory to secure the integration of all future expansion phases of the IX building. By protecting the baseline through uncompromising stage gates, rigorous factory testing, and absolute evidence currency, the Nexoris system eliminates the chaos of unverified construction. It guarantees that the infrastructure is delivered safely, the capacity operates reliably, and the handover occurs exactly on schedule.